How you guys doing? Good. So I'm another non-English speaking native tongue speaker, but I heard the other guy is from Brazil, so you kind of nowhere to escape. So my name is Ori, and we're going to talk about SVG in React Native. Um, why I want to talk about SVG in React Native? That's because SVG knows how to do like great, crazy, beautiful stuff. It has like 20 years of worth of knowledge and innovation in graphics, and we can just use it in React Native thanks to React Native. So let's start. So as Caroline mentioned, I'm a CTO and co-founder of a company called Lance. We just launched actually in August. And what do? We build the financial system for freelancers. So other than ask me question about SVG, if you are freelancers, come talk to me. It'll be interesting. Been doing React Native for the past, actually a little bit over 2 years now. Before that, done some front-end development with React, and prior to that, Android native development. So I kind of messed with both worlds, native and front-end. And if you want to catch me on Twitter, that's my handle. So we're going to have a two-part talk. First, we're going to cover some of the basics in SVG, in vector graphics in general. And the second part, I'm going to talk about animation challenges. So animation API in React Native has some challenges. I'm going to tell you all about it and how I overcame it with the SVG. So even before we talk about SVG, basically I want to talk about vector graphics. So what's good about vector graphics? Why we favor vector graphics over other things? So vector graphics basically is a programmable way of describing graphics on the screen. Rather than using objects like view in React Native or div in web, when you can only style it, like background and borders and width and height, but you cannot do pretty much anything more complicated than that. It's pretty limited. You can also use images in order to put some graphics on the screen, but that is even more limited. So because it doesn't scale for the right resolution on screen size. If you want it to be, you have to put more images. You have very little control over it, over the color, and over the behavior. And it's pretty hard on the bundle size too. Also, most chances that the designer you're working with is already using a tool that is based on vector graphics. So if it's Photoshop or Sketch or InVision, they all work with already existing vector graphics tools. So it's best practice to minimize the level of intervention as a developer to what the designer produces and to what the user is seeing. Actually, those considerations, that applies for all platforms, all UI toolkit, not just mobile, also web, TV, car, whatever. So how many here are familiar with SVG? Cool. So I'm going to run it real quickly. Stands for Scalable Vector Graphics. It's been around for quite a while, as I mentioned, all the way since 1999. It's an open web standard. What it is, it's actually a programming language. It's XML-based markup language. We all kind of used to XML, right? JS6 is XML, HTML. It's the language that we love with parent node, child node, attributes, reusable components, etc. Actually, there are some amazing stuff that you can do just with this language. I don't know if you're familiar with this drawing, but this is SVG. Let me just pull up the inspector here, and you can see that all of these are just SVG element. And you can start taking advantage of it and start messing it around. It's kind of fun, relaxing thing to do, or not. So, and it's highly documented on web. There is a great documentation in MDN that I really strongly recommending to check it out. And the basics of it, this is a web SVG code. you can just use those tags, and browsers will support it. And you could just stack. There are some built-in shapes come with the language, such as rect, circle, and text with attribute, and you can stack them all on top of each other. Very simple. It's thanks to a positioning system, which is kind of like the CSS abstract positioning system. What's good about it is once you position your elements on screen, it will maintain these ratios across all resolutions and platforms. So you just position it once, and it works on Android, on iOS, on the big screen, on the small screens. It's great. One element in particular that I want to point is the path element. So the path element actually holds the power of SVG. It's what it is. It's an element with a D attribute, and the D attribute is a series of commands to tell the rendering engine how to draw. Usually it starts with an originating point, such M22. In this very, very simple example, with just drawing a couple of curves, this is the shortened way of how to write those curves. Of course, the D attribute can get complicated real fast, just for very naive-looking image, but more on that later. So this is the power of SVG all in one element. And now moving to native, mobile native actually. So Android and iOS are already using vector graphical systems. This is how you see graphics graphics components on screen. Aside of images, PNGs and JPEG, everything is vector graphics already. So those are the packages that are in the SDK, the core graphics and the Android dot graphics. As you can see, they are using classes and objects which is kind of resembling the SVG. There is path, there is rect, and there is a wrapping element, canvas or CG context. If there are Android developers in the crowd, this is for you. This is how you write. This is an example of how you write path element in Android. So we just extend the drawable class, and in the draw method, again, like the D attribute that I showed you in web, you just imperatively pointing a series of commands how to draw the line. And you draw it directly to one big canvas by invoking the draw path. Over the course of time, there was some level of abstractions on top of these packages. There is a famous third-party plugin in iOS called Macau. And in Android, they actually built inside official SDK a vector drawable, which lets you write in XML format the vector graphics code rather than in Java, which is kind of a step closer to the SVG, but still, this is not SVG, they have their own elements here. So now, moving to React Native, finally. So React Native ships with a built-in library called Art. This is a wrapper on top of the vector graphics packages that I just showed. Still, it's not SVG. It uses different elements, but it lets you write cross-platform code to create vector graphics elements on the screen. However, it's a little bit heavy. This is why it's not linked automatically once you use React Native. You have to link it by yourself. And it has a lot of limitations also, such as you don't have events upon interactions, which is kind of basic. What I do want to talk about, however, is this package. So how many here are familiar with React Native SVG? Cool. So for the ones that are not familiar, I'm just going to say it's a great package. And what it is, it basically conforms the web standard into React Native. This is how you bring all your SVG knowledge from web or your designer's knowledge, and you just put it in React Native code. I'm going to show it to you. And it's maintained by those two guys, Magic is Might and Mikhail Sand. It's very living. I mean, they're working it as we speak. And I'm going to mention it later too. It's included in React Native community. You can, if you're using Expo, you can just use it. It's there. And it has rich documentation. And it does support the events such as touch events, which is really handful. And this is the same thing that I showed you in web, only in React Native. So as you can see, the same elements, maybe with the uppercase, but other than that are the same, with the same attributes. Actually, even the same values in the attributes, and you get the same result. So it's exactly like the web. Great. Another example. This is how you can see it, right? Yeah. This is how you do some text manipulation in SVG. and you know, every element that exists in SVG, such as depths and paths. This is how by the way, you can create invisible elements. Just put it in definitions element, and you can use it pointing with other elements. So this is how I make the text flowing on top of an invisible path. The path element is not rendered, just the text, but it knows how to render it based on the path that exists in memory only. If you just want to get the SVG file from a designer and just use it without messing around with the code, that is also supported by using React Native SVG URI, which is a different package, but it's built on top. It has a dependency on the React Native SVG. So this is kind of gives you the same experience as Lottie. How many are familiar with Lottie? So this is the same experience. Lottie gives you this opportunity of you know, importing JSON files, and you get everything the designer did with a very limited capabilities, however. But this is if you want just a very, very simple hassle, so you can do it too. Just a little bit what's going on under the hood in terms of React Native SVG. So I kind of drilled down a little bit. So a regular native view, and it's been discussed here this morning. It's all about bridge, right? And you have the view object on the JavaScript land, and every view object is mapped to a view and a view manager object on the native land, iOS or on Android. React Native SVG is built a little bit different in a way that every element in React Native SVG is not mapped to a view, but it's mapped to a method within one single view that acts as a canvas. So it maps to the draw path. This is an Android example, because I used to write Android. And those SVG elements with the attributes are mapped into a series of instructions in the mPath element, and it's mapped to a draw path method invocation. So this is a little bit slightly different than how regular views are mapped into native views. I think one of the most popular usage of SVG in web is creating charts, and beautiful animated charts like these. And usually when you talk about charts and SVG in web, you quickly come around to talk about D3. So probably, as I saw that most of you are familiar with SVG, so probably most of you are familiar with D3. So it's a JavaScript library for dynamic data visualization. What it is, it was built to work inside web browsers. Up until recently, it only worked inside browsers. It has the browser API baked in the code. But fortunately for us, recently version 4.0, which is I think not recently anymore, but it's there. What they did there, they separated it into different modules, and you have some of the modules are just generating data, generate visualization data. They're not dependent on any browser API. So lucky for us, non-browser environments such as React Native, we can use them. For example, we can use the D3 shape, and what we are using it in order to generate those long and complicated strings, and we don't need to like write them by hand. We can generate by invoking friendly APIs such as the D3. Let's, for example, draw this pie in a React Native application. So pie is a series of data. Let's take a really, really small and simple example, an array with the three items, and every item has a number and a color. And for each item in the array, we are rendering a path element from React Native SVG. And in the D attribute, we're going to populate it with a method that invokes D3 APIs. So this is how I did it. This is how I used the shape module in order to create series of arcs and all stacked together in a pie. And finally, the arc generator method invocation is what generates the D attribute to feed to the path element, path component. So that's what, in just very, very quickly going over the basics of SVG. and how you can just simply apply them into a React Native application using that awesome package. However, animation doesn't come that easy. Okay, everyone still sees the picture? Cool. And why is that? Animated API. Probably everyone who writes the code in React Native quickly gets to do some stuff in animated API. And animated API is all about animated values. You create an animated value, a numerical animated value. It only receives a numeric value, and you can run the application, run the animated value in this API timing.start. And if you need to animate string values, such as these values that goes into the rotate style property, for example, so you do have the interpolate API in the animated, and that lets you do that. Lets you map numerical value to string values. However, it's kind of taking a very naive approach of extracting the numerical value from the string, not more complicated than just parse int, invoking the parse int method. But we have a bigger issue, right? We have strings like these. I mean, in our case, we want to animate from various D attributes, and those D values that you want to animate from and to can be long, complicated, can be different in the sizes. What do we do? It's not very straightforward how to use an animated API with those. Not only that, other SVG elements receive other types of properties, such as object. The stroke dash array, for example. There are various strokes attributes. Strokes is usually what you use to draw some borders around shapes and style the borders. So one of them is stroke dash array, which tells you the interval between the strokes and the length of them. So they receive an object, in this case an array of 2 elements. Again, it's a little bit challenging to animate. So what do we do there? So I'm just going to quickly run through some examples, 3 examples to be exact, that pose those challenges and what I did to overcome it. First, the straightforward one, how to invoke animated API with React Native SVG. So if you have something very simple, such as this rectangle element, and you want to animate the X value, then you just do it. First, you need to create an animated component from the Rect in order for it to receive animated values. And in this case, I need to interpolate because it receives strings, but it's a straightforward interpolation. So interpolate, and you run the animation, and it goes just fine. No trouble there. However, assume that we want to do something like this. Okay? This is a nice way to present the pie, and to make it fill it up. In this case, remember, this is path elements. And path elements have those long D attributes. And we are using D3 shape module in order to generate those D attributes. So how can we put animated API here? So in this case, because we are using a very friendly API which has several methods and parameters, I looked for a single discrete parameter that I can increase over time. And I found my parameter that I can animate. So now it's just a matter of wrapping stuff. So I created this slice component that is now wrapping the path component, the React Native SVG path, and I'm making an animated component out of it, so it receives this multiplier that I'm increasing over time. And this is what it does inside. It just wraps the path and just delivers this animated value inside the path element. And the create pie slice now looks like this. So it gets this animated value, and it just uses it inside the D3 API. So now you can animate charts, basically, in React Native. Oh, a lot of animation. So the third example is some stuff that I did with strokes. So this rectangle has I'm animating two stages. The first step is this series of attributes, of stroke attributes. These are the values that can make this underline effect, and in the end phase of the animation, it turns into a full wrapping border with a little bit. If you can notice, it's a little bit thinner, so everything is like moving there. So there are various attributes there. Some of them are pretty straightforward to animate, like we showed. For example, the stroke dash offset is a numerical, so you can just use a straightforward interpolation. The stroke width. However, the stroke dash array, as we mentioned, it receives an object. So what I did here, I used another API that Animated API offers you, which is the add listener. So you can listen to every step in the animation, and you can bypass the declarative way by imperatively set the properties, set those stroke dash array property like by hand. So you use set native props in order to avoid the re-rendering. We're not using set state because we are using Animated API, and Animated API works around the set state rendering mechanism. And this is how we use it. And this is another way to bypass the limitation of Animated API. You might feel a little bit uncomfortable doing this because you actually listen to every step in the animation, and you might feel it's pose some kind of a burden on the bridge. We all heard about the bridge being a bottleneck in React Native performance, and you know what? You're actually right. However, sometimes when you're doing really, really small animations, such as this animation with the border, you just need to make sure that you're staying within the confines of 60 frames per second. And if you're doing all right, sometimes hacks like this can be tolerable. However, you might ask yourself, what about the rest of the animations? Are they native supported? So you probably all heard about use native driver, a really recommended way to use animations in React Native. This is the flag that makes all the animated code that you are writing shipped to the native beforehand, so you won't have the back and forth traffic on the bridge when the animation is running. So this is a perfect way to boost your performance in animating React Native. And not all the properties and for all the elements do support this property. Not even all the properties in React Native core elements, let alone third-party packages such as React Native SVG. However, when I did this talk about 4 months ago, actually it was not supported at all. But now I can say that most of the properties for most of the elements that I showed in React Native SVG do support use native driver, and that's thanks to the work that these guys are doing right now, and they're actively working on completing the entire set, especially the path element, which is very, very challenging, but we are working on it. There are some working example in the GitHub repo, so I strongly recommend you to check it out. And yeah. So if you want to check out those examples that I showed, you can check out the GitHub repo. And I hope you saw that every innovation and every knowledge that we've gathered for the last 20 years in web development can be just used in mobile apps, in native mobile apps, thanks to libraries like React Native. So that's it.